bit umbilical cord back
floating away, boys. I'm floating away.
Earth. Because you're connected into a second dimension when you're up in there. It's like, yeah, you're vibrating high up on this like full dimension of like conscious creation, and essentially tapping into like a God creation algorithm might be a good way of putting it. But
I don't think the right word is algorithm. No, like this consciousness. This is not an algorithm that was, some code program by somebody. This is the absolute field matrix, the force that binds everything together. This is the field force that keeps the electron from ever falling into and finally hitting the proton in the nucleus of an atom. I mean, this is that force there.
I mean, for anyone that has ever been able to, on a subtle level, feel energy or has been sensitive.
Hold on, though. I have to interpret this. Did you just essentially state that the energy and physics of what is creating in the movement of electrons is this God, essential God energy conscious, whatever it is? Is that a correct?
What I'm trying to tell you is that the interactions between these particles are happening through this field that occurs with a very forgiving matrix of, you consider it sort of like filling a tube with these clear beads that are spongy. Have you ever seen those? I'll use this example. Have you ever seen those beads that you can throw these little pellets into a container of water and they'll inflate and they'll grow into a sphere? And
yes.
Like 4 beads or something else like that.
Yes, that's exactly what they're called.
Right. Okay, so fantastic example of this thing. These things, they absorb the outside space. They reach a certain point where they're basically molecularly balanced, and then they stop growing. So the way that they flow, just imagine that there's this background field. It's like a lattice structure where all these things are kind of crammed in, and they're bouncy, and they have this spongy field against them. This is at the Planck scale. At the very finest scale of all things that exist, we have this structure that kind of, in terms of the way that it moves, is like these Orbeez, that they can congeal together and deform slightly momentarily, but they're field forces that make up the lattice, and they are way, way smaller in terms of their physical size than, say, the size of an electron, or the size of a proton, or the size of a neutron. These lattice points that spread out and fill the universe in a continuous, unending grid are basically pressed together, and they each have their own magnetic moment. So this magnetic moment can be spun and twisted and twirled. You could think of this like the zero-point energy field. There is physical stuff there. There's a reason for why the speed of light only goes a certain speed, right? It doesn't just instantaneously travel from A to B. There is a transverse wave that gets generated at the photon source, and it travels through free space in the vacuum and will arrive at the destination based on the velocity c and the distance between those 2 points. So why is there that time that it takes? What's it moving through? What is this little wave function of an electron's motion that we call a photon actually traveling through to convey that energy to something at a great distant point, such as the fact that we can see Alpha Centauri and all these other asteroidal bodies out there in the stars? Well, what is that point, right? So, if we think about the space-time as being connected to this underlying lattice structure that actually carries all the field forces and conveys them from one node to the next, and considering that they can be spun or reoriented, just imagine it like a bunch of tetrahedrons, tetrahedral magnet dipoles suspended somehow on a lattice grid, and they're slightly elastic to each other. They can't quite get closer, they can't quite get farther. Well, what these are, in terms of when we've investigated positron-electron pairs. So if we put enough photon energy into a fixed point in space-time to see what space-time is made of, what this universe is made of, the Large Hadron Particle Collider is attempting to disassemble the space-time. and look for the field forces that exist in that space in between, the liminal space that exists between all of these individual particles. And something really fantastic happens there at an extremely small scale, at the Planck scale. So I hope I haven't lost everybody yet. Can you guys hear me okay?
Not at all. You're doing well.
We can hear you okay.
Dorian McLean says perfectly said. So
Right.
you're explaining it on point, brother. Do continue.
Okay, so let's think about these field forces at the Planck scale, this cosmic lattice structure, right? So all these little nodes, just imagine that, we've heard about antimatter. Antimatter is a popular conundrum, and I want to bring this theory into this whole thing because this is a vision that I had earlier, and it ties right into this, and it helps explain part of what's going on here, but it gives us the underlying matrix that will build the foundation, the rock on which we are about to discover this sustaining conscious field force that makes the universe go. Okay, so we'll start with that. One moment, processing error.
Processing error.
Good. In the meantime, I'm just going to interject and tell my own little personal experience of when I let myself get far too space cadetted out because I stayed awake for 5 days straight working on some alchemy and like some science experiments and projects. But by the end of it, I was looking at the periodic table of elements of symbols of the alchemy symbols of the periodic table of elements, and it just like they all started moving around and connecting and like explained made this conscious like connection to me where I like tapped into this source consciousness and it explained that they like came alive and became this like God code thing. And it was the most messed up experience I think I've ever had. But
I got it now, by the way. But,
well,
yeah,
I still, I'm still deciphering it bit by bit, and yeah,
gods can control physical matter.
Things get weird when you're awake for 5 days. I did that on purpose as an experiment, and you will start to see things.
And hear things. The shadows do come alive. The
yes,
whispers
the
begin to speak.
The shadows.
And you connect into a different dimensional realm, and that is a whole other topic for another day.
People in the shadows, little figures, and they didn't go away. It was weird.
Okay,
yeah, but we're getting off topic.
I think I am ready to get into this. So this is where it gets good. The
energy, frequency, vibration.
So if everybody's ready, now let's delve in. Okay, so there is an interaction between two electrons that are flowing through conductors at an orthogonal angle. When these crossed fields of the conductors, the electrons that are flowing through the conductors, interact with each other, there's a chance, there's a possibility. It doesn't happen every single time. It doesn't happen with every single electron. This is not like a universal guarantee that this is going to happen, but there's a chance that two electrons will happen to be at exactly the right distance apart along the same path length with equal energy, where they can basically repel each other from two conductors that are crossing. And when they do this, they will be forced to swing 90 degrees to the direction that they were moving down the conductor and take an entire loop around the outside of the wire over and just between that area between the copper and between the insulator of a common wire. This will happen because of the magnetic flux interaction, that you'll have this orthogonal motion. And if you look at it side on, you will see the omega symbol. This means that the electron took a longer period of time to move through that space than it otherwise would have had there not been another electron moving through the wire beneath it. And had their fields not interacted, they would have not made this, weird pathway. They would have not changed their trajectory and linked with each other like this. But when they did link with each other, they formed a pair. And when they paired up, this Cooper pair, this is the phenomena of superconductivity emerging from a field interaction at the atomic, in the atomic lattice at the Planck scale, because this rebound effect from the background field of all these orientable magnetic dipole moments from the structure will rebound to try and convey the magnetic field pole orientation of the motion for every charged particle. So every single time an electron moves in a line, in a straight line, all other electrons that are anywhere near that electron that's moving in a straight line, they'll want to get pulled into and move along with it. They are going to want to follow the same exact path because the path has been basically cut out for them. It's sort of like walking a trail in the woods. You know, if people walk that trail in the woods, everybody tends to walk the same trail. It's the reason why lightning bolts form in the ways that they do. It's the split and the fractal for why we see the exact shape of the V in the curve of the lightning bolt when it breaks apart and splits in two different directions.
So what's your thought on Mercury? Because that was where we first discovered superconductivity in the first place. When you supercool Mercury, you get that effect.
Well,
so is it just that you have
room temperatures, though? And you get superconductivity in mercury vapor at high temperatures under high pressures.
Right. I'm just saying that when you have it at a specific temperature, you're going to have all the atoms in the mercury vibrating at a specific rate. And you're going to have a higher likelihood of that kind of collision, basically, if they're going at a specific rate and at a specific distance between each other. Because also, you know, it's going to expand if it's hot and contract if it's cool. So the distance between the same amount of atoms is going to be different depending on the temperature also.
Right.
So it's just a question of the likelihood of this happening.
Yeah, they really do need to they need to get that cross-field path interaction in order for them to link up like this. As far as the way that I'm seeing this here, we end up with this omega symbol being created out of the motion of the electron as viewed from a certain perspective, and you could just simply look at the way that it flows around the conductor as being a representation on a 2D plane of this three-dimensional interplay for where this electron tends to have its momentum re-vectored due to the velocity of the extra electric field from the other electron in a different frame of reference.
So, Jeremiah, do you have a decent enough schematic little drawing that maybe you can briefly screen share to show? I don't want to give it away. You know, this is for you to tell, but the shape of what the motion of the electrons are when they converge. I don't know if you wanted to screen share like a little drawing.
I'm going to. So
yeah,
there are also superconducting materials that are only such when they're under super high pressures. So I don't know.
Here's the thing. Get this. Okay, so back in the day, there was this video series called Energy from the Vacuum, and this researcher, Deborah Chang, I think I'm pronouncing that right. Deborah Chang had found that if she crossed two different carbon nanotube fiber nets together, if she crossed them orthogonally at 90 degrees to each other and have them nice and tight, and she pressed approximately 150 pounds of pressure on the cross-sectional area where they were intersecting, that there will be a negative resistance. And so this was the video that my brain seen, and when it seen it, it said, okay, the way that the electron must move from one carbon nanotube to jump and orthogonally transit to the other carbon nanotube of the other lattice structure for the different thread, it has to take this pathway. And the pathway that it takes is the Om symbol. If you look at the symbol, the pathway that it takes is like a little loop-de-loop in the free space through the vacuum between these 2 points. So I seen it clear as day. It takes this shape. I viewed it 45 degrees orthogonally.
It also kind of looks like a coronal mass ejection.
It does. It's this very classic shape, and it's just simply the redirection of the electron velocity and its momentum, because it does have a physical mass. And that velocity, its physical mass, keeps it going, so it overshoots the target. Instead of jumping from one carbon conductor to the other, it overshoots, and it has a swing back around. It goes around the outside the long way around this nanotube, and then comes back on the other one, and then lines up with the second electron that was already flowing orthogonally from a different nanotube, and they pair together because their spins were aligned, and they were actually the catalyst that caused each other to be pushed apart. So when they do pair up, they two repair. That's a superconductive action, and they no longer are able to interact within the atomic lattice. They don't have to deal with resistance or the fluctuations of the motion. They're now going to travel as an evanescent wave over the surface of all these atomic nuclei, just over the valence shells, sort of riding the wave as a boundary layer effect. Evanescent wave, like an Alvin wave.
Absolutely. You just hit the nail on the head for me, Jeremiah. Like, huh.
I see it, Gerald.
Your words are as eloquent as I don't even know.
I see it, Gerald.
As a vision from the cosmos, right?
It might be a little bit difficult for the viewers without a graphic.
But, right. I mean, I want Jeremiah to just show. I didn't want to give it away. It's for Jeremiah to show what it looks like.
Okay, guys, here we go.
God is in the fields.
So, Jeremiah, let me pick this. Let me find him in my text.
Jeremiah.
Yeah.
Just before you do that, I'm not trying to, steal whatever. When I was showing my coil, it was right at the moment where you were saying cross section or lattice. So, by all means, man, go for this.
I want to do cross section back to the lattice.
Yeah, so we got to figure out the exact angle that we need between different sections of the wire, just to make sure that we have the highest likelihood of it happening.
We can wrap it up and try to steer it into this kind of interaction. We can try to steer this and create it so that it radiates out that extra indifference. But this field is accessible. It's like a inexhaustible energy source, I guess you could say. I mean, the electron keeps on spinning around the nuclei. It does not fall in. All these valence shells, they just keep on whirling. Right now, you're made of all of these electrons and these protons and these neutrons and these electrons. They're not pulling in towards the proton. They're oppositely charged. They're attracted to each other, but why don't they ever connect? The force that keeps them from connecting, the force that moderates and modulates their interaction, is a force field interaction. It's an orthogonal force field interaction that's the underlying matrix at the Planck scale, and that's what I'm calling God here. That's where I see God in the fields. God is this field that exists at the Planck scale, at that lattice structure, that is maintaining this interaction so that the whole universe doesn't fall apart, basically. The universe would fall apart without this force.
Can I just come out and say the shape that we all have seen? It's infinity. The motion of the electrons converging and looping around, it creates infinity.
Infinity inside of a gyroscopic motion, creating a sphere.
So my question:
outside of that.
When you have a Cooper pair, do they have the same or opposite spin states when they're orbiting each other, or does that not matter? Do they even have to be alternating at the same rate?
I believe they will be paired opposite, like orthohydrogen. And I think the Cooper pair is probably very analogous to orthohydrogen.
You really hit the toughest questions, Jeremiah, because the standard model cannot explain what you're talking about either. And I was trying to hypothesize that maybe an electron in motion emits a magnetic field that repels it from the proton or something like that. But I don't know, it's just I'm not at that level yet.
Well, are you familiar with a ball-bearing motor?
Right, there it is. That's a perfect example of this extra force. That's a perfect example of exactly how this happens. The ball-bearing motor is a demonstration that this occurs.
Yeah, Eric, I've seen it. Eric Dollar did
that. Is that like the balls on the outside of the circumference of the system itself?
So you have a shaft and you have ball bearings, like the normal kind of metallic ball bearings that you're thinking of, right? Two little discs that have balls between them. And so you have the current that's running through these ball bearings, through the shaft and all the way to the other end. And the interesting thing about it is that when you spin it, it'll just keep accelerating in that direction, but you can start it up in either direction without changing the polarity. It's just whichever direction you start.
I've also heard too, yeah, you can run it any direction. It does demand a lot of current to make that motor work. I've seen it work. Eric Dollar's got a video where what he did with Chris Parson, and they actually demonstrated that on stage. So it only takes about 6 volts, but it needs about 6 to 10 amps to actually make that ball bearing motor work.
Maybe I should flip this. Yeah, let's do that. All right, so that was the winding machine. Now, yeah, I see now that winding machine makes so much more sense. Adam and I had both talked about that. So, yeah, this orthogonal motion creates a certain type of shape, a field geometry, when an electron jumps from one point to the other. So let me just flip over to this page here, and let's just see. So I had a vision the other day. I seen this symbol. I seen a repeating series of these symbols, field aligned. In my mind, this vision represented coherent matter. I don't know what the heck that symbol means or what it is. I didn't know at the time, but it is slowly beginning to make a whole lot more sense. And there are just different ways and modes of this type of field interaction. So I'll go on here. So this is the latest. And I'll walk you through this. So here we go. Crazy guy vision, right? If I've got you so far, if you're still here and you want to know about this, crazy guy vision, stay around, because here we go. I'm going to try to explain to you how we can generate this super weird phenomena, a force interaction between electrons using conductors or conventional materials that we already have. And after, I'll tell you the story of how I discovered this and what actually led up to this sort of vision, or this breakthrough, if you will. And I could be wrong. I just want to throw that out there too. I could be totally wrong. I may be incorrect about my analysis of this. I may have not gotten the right conclusions, but here we go. So if we're looking at this thing here as a wire, this is a wire. Looking at its, cross-sectional area, it's facing down in a direction. So we have one wire facing basically like this. And then we have another wire orthogonally placed 90 degrees like this. Now, in this case, these two wires are insulated, and so something interesting is going to happen. So just say that this whole area here, I guess I just will shade it. This is one copper wire. I just want to make it clear. And this is another copper wire we're looking at. Orthogonal coming on. So goes underneath, right? So imagine that we have an electron scooting along the outside edge of this copper wire. There are plenty of protons and neutrons, plenty of nuclei in the crystalline lattice of this wire to carry this single electron that we're going to concentrate on for this example. The single electron, this is a free electron, a true free electron, meaning that it's not bound in the valence shell of any atom. It does not just simply jump completely coherently from one atom to another. It can easily glide between them. It's just a little bit dislodged. It's a free electron. So it's moving along this wire. It wants to go its merry way and head straight down it along the same path along the bottom side in orientation to this other wire here. But as it does, there happens to be a second electron in this other wire that is crossing orthogonally at 90 degrees, so you have a cross point between these two wires. And right at this cross point here, what's going to happen is the electron flowing down this main wire, it's going to experience the electric field repulsion because of its relativistic velocity. It's moving faster than the constituent protons inside the nuclei of these atoms that are composing this copper wire in this example here. So this nuclei, the electron is going to basically be repelled away from this other free electron in this other conductor, and it's going to take this pathway. As it's moving along, it gets pushed away because this other electron comes in, and it takes this orbital long loop path. The pathway, when looked at from the side, forms this shape. Okay, I drew that horribly. That was absolutely grotesque.
But there's the omega.
You get the idea.
It's a very tiny game of I'm not touching you.
Right. You're looking at it, if you look at it dead on, so if you look at your two wires, basically, you know, perfectly cross-field interactions. Let me just try to grab two physical materials here. So if you're looking at them dead on from the side, like that, where the line from the X-acto meets the purple pencil, right? If you look at the path that the electron takes going on the bottom side of the purple pencil to the X-acto knife, it will whirl around the outside of that wire, take a large path, and exit out the X-acto conductor here. So when it does that, it has been redirected. If it does not redirect, then it actually just makes that shape as seen from this view, a single-sided view, and produces this omega shape. Well, this omega shape, well, it's actually doing this long pathway, this single electron, this charge that has received its acceleration force, the reason for why it has any momentum at all, any motive force to generate electricity, has already been granted that force, and it now is trying to reach its destination, but it can't, because, of course, there's all these other atoms in the way. So it's trying to slowly make its way there through the copper, you know, slow electron drift velocities, that kind of stuff. But these field repulsive forces, they force it to go in this kind of loop. Now, this loop can happen inside of a conductor. This can happen all the way around the outside of a conductor. If these were carbon nanotubes, this would actually go around the outside of the whole nanotube. If this was a copper conductor, this may happen just at a tiny little distance away from the surface of the conductor, and a conductor may be much thicker on the top of the page here. So the basic idea is you've got this motion that the electron takes, trying to chase the second electron as it's being pulled along. And so each electron is kind of like a little ball. It's like a bead on a bead with a hole in it. And imagine that there's like this bead on a string. This electron has this dipole moment. So if we were to try to, say, put a force like this on this electron, it's got some momentum, some spin momentum, so it's going to take a little bit for it to accelerate, and it will take a strange motion. So instead of, say, just taking a sharp 90-degree curve like that, it might instead take a curve more like this. Or just a little loop because of its spin, because this has momentum. Well, this little loop, while it's doing this, it takes too much time doing this loop. It should have done this, but it instead this. And when it did it, it opened up a gateway for energy to pour in from the outside. So basically, the electron time, in terms of the amount of time that it experienced, it has to accelerate in order for the moment of inertia and for equilibrium to be maintained in the whole universe. This has to be aligned so that this electron will basically give back its energy. So this electron, as it's doing this little whirligig shape here, it's in a negative energy state. It's in an entropic state. It will steal energy or momentum from the outside in order to try and realign to its new pathway. That's where we basically get this concept that we've been hearing about of this energy vortex. So if we take a look at here, I'm going to tell you how you can do this with carbon. Let's talk about superconductors for a second. So here we have sort of this view of these two conductors. we're looking at the end of a end of a carbon nanotube and the end of a carbon nanotube. Okay, so we're starting out this red line here. This is the electron coming in from the left side along this conductor, but it's facing towards the bottom side. So basically, it's that direction. And then we have this blue line represents the electron that's moving towards us, where this electron is moving away from us. This electron is moving towards us in this bottom conductor, and this is represented by the blue line. And so it's got its electric field pointed right. So what's going to happen is when these two electric fields, if they happen to cross exactly at this point where these wires are closest, if they just happen to intersect at the right angle, they will push an electric field force against each other, the negative potential of these electrons, and they will repel each other so that they won't continuously float in a straight line down these wires or conductors. They'll be pushed away because they got too close, so they basically bounced off each other's fields. The thing that allowed them to bounce off each other, this is where the Ohm, the God is that I'm talking about in this whole entire architecture.
So
double
they
Ohm.
bounce off. One electron on the top carbon goes around the carbon nanotube lattice, and it comes back to the same point on the other side as it's linked with this other electron on the second current carrying conductor. It goes around here. And then when they link up here, they link up together at this point, and now both electrons, the one from this carbon nanotube where the electron was moving away from us, and the one from this carbon nanotube where the electron was moving towards us, they both taken this loop path on opposite sides, and they've linked up together because in this motion, they were able to half spin and Cooper pair right at the surface. And so now they travel together as a Cooper pair along the surface. They no longer need to jump in and out of the lattice structure of the carbon atoms because they are paired together and they have an evanescent field that they are riding on like a bubble.
So this would normally just be considered interference, right?
Right. This interference seems to cancel. We can't really measure it, but this thing can move basically frictionlessly. There's no friction here. There's no kind of any kind of resistance to motion. When these electrons pair up and it jumps from one conductor to the other, we have this negative resistance region, and they're just going to travel down. So what we want to try and do is maximize the number of times that we can make this event happen, where we have two different electrons that are coming from two different conductors along their current path, and that they actually jump from one to the other. They take this pathway, they make this omega symbol, and then they will pair up together and create this superconductive state.
So that's going to be really annoying to tune because it's going to get more and more out of tune right before you get in tune.
Right. So just imagine like if you had a spring, and this is probably the easiest way to imagine how my brain finally backwards interpreted this motion when I was thinking about it earlier today. Just imagine that you take one single loop of a spring that's fully collapsed, and it's one of those stretchy springs, right? So it's already as close as it can be to itself each wind, and you pull it apart. Well, if you were to take a sharp bend and try to make one of those bends go 90 degrees, so you'd have one at 45 degrees, think about the pathway of that loop and look at it from the side. That's basically your omega symbol there. That's the path that the electron takes around the outside of the conductor. It's got this orbital momentum, this angular momentum that it has to maintain, and it keeps it, and that forces it to move in orthogonal path. And here its time slows down. So I think this actually affects the lattice structure in such a way that energy from the outside.
It's all about the flow.
So do we want to correlate and bring this back to some experiments that have already been done? Jeremiah, I believe you have already duplicated one of them, Harold. And you're going on to the CromRay next, correct?
Yeah, I'll be testing the CromRay generator because that thing is a really interesting apparatus. Bedini played with the CromRay generator back in the day. Noticed that it produced a very, very strange phenomena. There was cold air blowing out of the iron rotor even though the iron rotor itself was hot, if you were to stop this generator and feel it with your hand, the core piece was hot, but yet there was cold air blowing out the sides. Now, how is that possible? Well, the way Bedini explains it, there's this negative energy vortex. Now, that's a heck of a string of words. I don't know if you want to look at it that way, but the way that I see it is there's a specific atomic motion that happens inside the
Yes, sorry to interject, but it's endotropic and endothermic reaction.
It's entropic and endothermic, right?
Yeah. And that it's this vortex, and it's taking the radiant energy from the environment and then cycling it down through the spiral twister vortex. And for those that haven't seen last month's APEC, where I believe, was it John who went through the twister, what he called the Freemason third degree twister initiation, explaining the vortex powers. It was quite something, and connects exactly into what Jeremiah is describing and talking about.
Oh yeah, just grab myself some for a second. You know, like when I had this crazy vision in my head earlier, I called a bunch of people and I'm like, I have to tell everybody and see if I'm absolutely, a mind case with all of this information, and I could be totally wrong. I just went out there basically searching for somebody to tell me that I was wrong.
It seems like a series of dots connecting. A series of dots connecting, going all the way back to anyone that's been able to feel their own energy field, to you being skeptical about me being able to feel magnetic fields way past what would be expected, because fields don't stop abruptly, they lose coherence over space and time. And replicating Harold's experiment, the subharmonics, you didn't actually notice that. I found that curious. They're very present.
I do tell people that I tend not to notice the subtle energies, or at least so far as
normally you notice the mechanism stuff. Like subharmonics were so presenting for the duplication of Harold's experiment. I could feel the vibration from the table going all the way down through the legs, through the floor, like 6 feet away. I could feel a vibration on the floor coming up through my feet. And as I got closer to the table where the device was running, it was much more obvious, and that I was feeling subharmonics from the mechanical motion of the disc spinning. And I was wondering if my sensitivity might have been increased in consideration of what you said. You had longer exposure and it affected your mood in a positive way.
It did, yeah. So I was holding the permanent magnet against the rotor there, and I was just playing around with field orientations, trying to find the one that would load the motor down the most. And I'm like, okay, well, these two permanent magnets I have. So basically, the thing that I'm talking about now, for everybody that's listening in, this is a disc. It's got a bunch of magnets strapped to its face. So 12 ring magnets strapped to one side of a disc, and 12 opposing magnets on the exact opposite side of that fiberglass disc. And this is attached to a small DC motor. These ring magnets are whirling around. So it's kind of like the Graviflyer disc that has 6 magnets, but this is 12. So I was just playing around with that. And I was holding a large 3/4 inch by 3/4 inch N42, allegedly N42. It's probably like an N38. Maybe it's even weaker. I don't know what it is. Probably an N38. Neodymium magnet cube. Got it off Amazon. So not super powerful. The fact that I was able to peel it off the rest of the magnets with my hand at all tells me that obviously it's not that powerful, because there's no way I'm superhuman and have the strength to peel off a field like that. Right? It's not super up close. But while I was holding it there, I felt it grab hold of the rotor magnets that were spinning around this disc, as if it had built up a superposition or a connection to the rotating magnets. And this cube magnet in my hands it felt like it was stuck to the spot, almost as if there was like some spongy double-sided tape there that I was pulling against. So, you know, the 3M invisible wall case where it felt like he got stuck in this 3M invisible wall, in this invisible wall, this electrostatic wall, and he had to kind of peel himself out of it. That's the way this force felt. It's like exactly what David was describing in that case when he went to investigate the 3M plant that day. The same types of field force interactions, I think, are taking place here in these permanent magnets. And I think that they have to do with the electron valence shell spins of the permanent magnets interacting with each other and being basically forced to reorient their dipole moments because their fields are so close to each other that they're basically like trying to magnetize, almost as in to induce eddy currents into the rotor magnets. And so in doing this, it just felt satisfying. It was like something that I'd done before. It was the first time I'd ever done it, but it felt like something that I had done before, done many times before, lifetimes before.
It's like something natural or
right.
Organic. Yeah.
It was incredibly natural. It was incredibly organic. It was just a really, really weird sensation and an experience from something so simple as a bunch of magnets strapped around a disc spinning at, you know, reasonably mild velocities, maybe 5 to 10,000 RPMs. And yeah, I know holding a 3/4 inch cube neodymium magnet close to something that's going at 5,000 RPMs, even if it is only 3.5 inches to 4 inches in diameter, is probably a kind of crazy thing to do. But hey, you know, science demands interaction. And so I wanted to feel these forces with my hands. I didn't want to just simply explore them mathematically and poke wires at them.
Hey, evolution calibrated those hands over millions of years.
I spent 8.5 years using these hands to calibrate different equipment across the industry, seen 300 different companies. I know how the industry in this entire country works. Seen it all.
Hands are great.
You know, but these hands were calibrated for all that stuff, and in all that experience, they felt something that they'd never felt before. These hands felt a new field interaction that I knew did not make sense. It just did not make sense. It wasn't there before, and I could not wrap my head around what the heck this thing was. There is.
I finally feel vindicated about feeling magnetic fields interacting with each other for permanent magnets. You know, like I thought I sounded crazy. It's like 2 permanent magnets in each hand, and they're way far apart from each other. I can still feel the interactions of attraction, repulsion, or reversal. And it doesn't make sense, but there are like these interval nodes where they continue to interact and they just lose coherence over distance.
There are people who have implanted in their fingertips magnets so that they can more strongly feel fields, and apparently it's kind of plug and play for your brain where it just immediately adapts to it and you intuitively understand it.
Are you saying people do this manually, like
they'll surgically implant little magnets into their fingers? This is an actual thing.
Wild. Wow.
Yeah. Biohackers are weird.
I play with fields every day, and I can testify that what Jeremiah is saying is absolutely true. And the right fields you can feel at all times. And at the right frequencies, they help heal you. What they do is they activate your healing ability in your body, and then your body takes over for that healing process. So what Jeremiah's onto it's profound.
A while back, one of the people that were commenting about time, possibly slowing down. I'm sorry, it was a while back, but that made me think of.
Was it Adam, Space Case Zero?
No, it was someone else. But it made me think of the Crom ray experiment, in which it pumped out cold air from the magnets. And me and Jeremiah were speculating if there was some kind of superconductivity going on with the electrons and time being slowed down and the electron's spin state actually changing to create this phenomena with the magnetic fields interacting and putting out this cold air.
Yep, and I think that the loss in the momentum in a forward direction, Brownian motion, just remember, is nothing but velocity. So when we think of heat, we are thinking of velocity. Brownian motion is the velocity that a particle has under nominal conditions as it has reached equilibrium with the surrounding environment. And so when particles are moving faster, they bounce off each other more often. That you could say is a frequency in terms of the period of time between interactions. But each time they interact, there is this little exchange of momentum between these particles. And so this is what gives us heat. Well, if we could say control the exact motion, so the things that give us heat is actually the electron shells. The electrons are what give us heat. And we know this for sure to be true because heat that we feel in terms of thermal is something hot, is something cold. It's acting through the electrons. And we can tell this to be true for sure because we can take electron beams and we can use them to actually heat up or cool down an object. So, say for example, I can create positive ions, a stream of positive ions in a low pressure environment, evacuated environment, and send them towards a cathode plate, a negatively charged plate that has an excess of electrons. Well, let's say that plate is hot and I want to cool it down on a conveyor line. Well, the way that I'm going to cool that item down on the conveyor line is by heating it with a bunch of positive ions and having it negatively charged so that the electrons that are in it will actually take their momentum, the thermionic motion of all the little vibrations that are transmitted through the free electrons in the structure, whether it's a dielectric or a conductor, and I'm going to use positive ions to neutralize the surface charges so that they don't show up anymore. And I'm going to steal the energy away.
So
with this, I can basically cool down a part almost instantaneously on a conveyor line. This is called electrostatic heating, electrostatic cooling. It is a thing. You can look up the patent numbers for it. There are plenty of patents, plenty of devices that have been made and are actually in deployment and being used today in various specialty applications in industry.
As well as in all of the major electrolysis hydrogen systems, it's a major component of it as well. And what they claim is something impossible, so they claim to debunk it with it, but really it's the negentropy and the endothermic reaction taking radiant energy from the environment and not actually creating something out of nothing. It's just a higher dynamic dimensional energetic system.
So I think there might be some resistance to this technology because, like, if you look at coronal mass ejection. Yeah. When it loops, the problem is that when it pinches and then it gets accelerated because it suddenly has the same charge